Hello, how are you all? I hope you all are fine and doing well. My name is Sayyida Fatma Rizvi, and after a very long time, I'm bringing you the video. I miss you people a lot and my YouTube channel. How are you all? I hope you people are all fine and missing my another YouTube video. So here I am bringing another YouTube video which is related to the quantum physics. Now, quantum physics is one of the most important and fundamental branch of physics that many of the physicists are confused about. It is one of the difficult branch of physics as well that no one can understand it. But here, as I am a challenging person, so I am going to bring the series of the quantum mechanics, where I would describe you people in details and in the simpler point of view about the what is the quantum physics, so everyone understand about the quantum physics in detail. It is especially related to the matter, energy, light, atomic and subatomic particles. So it is all about the wave theory, how the atomic particles work upon. We can find out the speed, accuracy, momentum of the particles in this whole subject, right? It involves basically chemistry as well, and it involves all the function of the particles and the atomic and subatomic particles, and the wave theory, function and accuracy of the particles, each and everything. So we will discuss about the introduction of the quantum physics, and I hope that you people like the subject and do share, like and subscribe to my channel, as I am bringing the most difficult topics for you people. It's my right that you people just do subscribe to my channel, and I want more and more views as I'm working harder on these subjects, so I want the results in return. I want the response in return, right? So keep boosting me. Let's start. What is the quantum mechanics? Let's start. What is the introduction of the quantum mechanics? We will discuss about the macroscopic particles, Newton physics, right? So before discussing about the quantum physics, we would discuss about, first of all, about the classical and microscopic particles, and then we would go further and discuss about the discovery of the physics, nature of the particles we would study, and how the quantum mechanics work. So, nature of the particles need means that I have described before, that we would discuss about the wave function of the particles, how the particles work as a particle and how it work as a wave. We would discuss its dual nature and how the quantum physics work, what are the applications of the quantum physics that we are using in this world. So each and everything we will discuss today. Let's start. What is quantum mechanics? So, quantum mechanics is a fundamental theory in physics that provides the description about the physical properties of the nature at the scale of atoms and subatomic particles. So, basically, it's the fundamental theory in physics. We all discuss about that describe the physical properties of the nature. I have discussed before of the atomic and subatomic particles, like protons, electron, neutron, they're working, and other particles as well, each and every lighter particle that Newtonian physics was unable to explain. The quantum physics explain each and everything, little bit, each and everything about it. So basically, all about the universe system, particle system, atoms. We know that when atom is the smallest particle of the nature, when the atoms combine together form molecules, and whole and molecules combine together form a whole universe. So classical physics and Newtonian physics are unable to predict about these microscopic particles. So quantum physics come into being and describe about the wave nature of the particles, and whole chemistry is involved in it. So we will discuss about it. So it is the foundation of the quantum mechanics include quantum chemistry. Obviously, I have told before, quantum field theory, quantum technology, and quantum information science. So wave theory of the electron and the hydrogen atom at the different energy levels. Wave function of an electron, you know that there lies the two energy levels of in the hydrogen atom, the lower energy level and the higher energy level. So we cannot predict the exact location of the electron at the lower energy level. When the electron emits its energy, it lies at the lower energy level, and when it absorbs the energy, it lies at the higher energy level. So electron continuously moves side by side. So wave so quantum mechanics just describe the wave function of the electron in the hydrogen atom at different energy levels. Quantum mechanics cannot predict the exact location of the electric particle in the space. Now here we are discussing about the space, that quantum mechanics cannot define that here is exactly the particle lies, the exact location of the particle in space, but it can only discuss about the probability of the finding the electron at different locations. So let's say it's an electron. So quantum mechanics give the probability of finding an electron at different location, that here lies the probability of the electron in the space, that here the electron exists in the space, but it cannot predict the exact location of the particle in space. Okay, now let's discuss about the classical physics. Classical physics, the collection of the theories that existed before the advent of the quantum mechanics, describe the aspects of the nature at the uh, ordinary scale, but it is not sufficient to describe the small atomic and subatomic scales. Most theories in classical physics can be derived from the quantum mechanics as an appropriate valid at large macroscopic scale. So you can see we have discussed about the Newtonian physics in detail related in our previous videos. Go and check it out. Classical physics is all about the Newtonian physics, and it's a further elaboration of the Newtonian physics, and it is one of the great invention as well of physics, but classical physics is unable to describe the subatomic particles and the atomic particles, which the quantum mechanics take the responsibility to define and explain it really well, right? Now, what is the quantum mechanics? What is the difference of the quantum mechanics with the classical physics? So, quantum mechanics differ from the classical physics in that energy, momentum, angular momentum, and other quantities of the boundary system that are restricted to the discrete values object. Systems that are restricted to the discrete values objects that have the characteristic of both particles and waves, and there are limits to how accurately the value of the physical quantity can be predicted prior to its measurement. Give the complete set of initial conditions. So here you can see how can classical physics differ, how can quantum mechanics differ from the classical physics in terms of energy. It describes about the energy of the particles in details. Now secondly, it describes about the momentum of the particles in space, the angular momentum of the particles, and it also describe about the discrete value, quantized value of the different particles, right, that have the characteristics of, okay, I told you before that the particle has the dual nature. It possesses the character of both particles as well as the wave, and describe about the accurately the value of the physical quantity. Okay, give the complete set of the initial condition, uncertainty principle as well. So let's discuss about the introduction of the quantum mechanics. Quantum mechanics arose gradually from theories to explain observation which could not be reconciled with the classical physics. So it is based on the observation that the quantum physics failed to explain. What are the contribution of scientists in the quantum mechanics? What are the distribution of the scientists in the quantum mechanics? Max Planck solution in 900 to the black body radiations and the corresponding correspondence between the energy and frequency in Albert Einstein in 1905 give the paper which explained the photoelectric effect. Okay, so Max Planck's give the solution to the black body radiation, which is the important topic in the quantum physics. And then another important invention in the quantum physics is photoelectric effect, which is produced by Albert Einstein. These early attempts to understand microscopic phenomena, not known as the old quantum theory, lead to the full development of the quantum theory. Okay, now the full development of the quantum theory is introduced in the mid 1920s by Niels Bohr, Schrödinger, Heisenberg, Born, Paul, Dirac, and others. So there are many other contributions of the scientists as well, which include Bohr, Schrödinger, Heisenberg, Born, Paul, Dirac, and others. The modern theories formulated in various specially developed mathematical formalism. Okay. So there are some mathematical formulas related to all the theories we would discuss further in the videos. Let's discuss few of the details about the black body radiation, Max Planck theories, photoelectric effect, and Heisenberg principle. What is the black body radiation? So black body radiation is the thermal electromagnetic radiation within or surrounding a body in thermodynamic equilibrium with its environment emitted by the black body. Okay, so these are the thermal electromagnetic radiation. Electromagnetic radiations are emitted by our body as well, by our surrounding as well. So black body radiation is the thermal electromagnetic radiation within or surrounding the thermodynamic equilibrium with its environment emitted by the black body. So, black body radiation are basically what? The thermal electromagnetic radiation surrounding a body by thermodynamic equilibrium with its environment. So, it is surrounding a body, and what are the conditions for that? It is emitted only when the body is in the thermodynamic equilibrium with its environment, emitted by the black body. Now what is black body? Black body is an idealized, opaque, non-reflective body. Okay, opaque means empty. An idealized, empty, non-reflective body is taken which emits the thermal electromagnetic radiations when the body is in the thermodynamic equilibrium with the environment. It has the specific continuous spectrum of the wavelength inversely related to intensity. Now there lies the inverse relationship between the wavelength and the intensity. So greater will be the intensity, the smaller will be the wavelength. Greater will be the wavelength, the smaller will be the intensity. There lies the inverse relationship between them that depend only on the body temperature. Okay, intensity depends upon the body temperature, which is assumed for the sake of calculations and theory to be uniform and constant. Here they have taken the temperature constant for the sake of calculations, right? But intensity of the electromagnetic radiations only depend upon the temperature. Now, Max Planck's solution of the black body radiation: every physical body spontaneously and continuously emit electromagnetic radiation and the he proposed that every physical body spontaneously and continuously emit the electromagnetic radiation. And the spectral radiance. What is spectral radiance? Spectral radiance of the body describes the spectral emissive power per unit area. So, spectral radiance is the spectral power per unit area per unit frequency for the particular radiation frequencies. Okay. So the spectral radiance is the spectral emissive power per unit area per unit frequency for the particular radiation frequencies. Okay. The relationship given by Planck's radiation law given below show that with increasing temperature. Now Planck's given the solution to the black body radiation, he given the importance to the temperature, that he shows that with the increasing temperature, the total radiated energy of the body increases. Now he said that when the increasing temperature, the radiated energy of the body increases, and the peak of the emitted spectrum shift to the shorter wavelength. With the increasing temperature, the wavelength decreases, and the peak of the wavelength shift towards the shorter wavelength. Peak of the spectrum shift toward the shorter wavelength. So he said that with the increasing temperature, the total radiated energy of the electromagnetic radiations increases, and the peak of the spectrum of the electromagnetic radiation shift towards the shorter wavelength, because the wavelength and the temperature are inversely related to each other. According to this, the spectral radiance of the body for frequency. Okay, now the spectral radiance depend upon another factor as well, which is about the frequency, and the absolute temperature is given by. So basically, spectral radiance is the function of the depend upon the following factors: frequency and the absolute temperature, and it's a function of the absolute temperature and frequency. So the spectral radiance is the spectral radiance is given by 2hv cube divided by c square ehv divided by kt minus 1. So spectral radiance is directly related to the cube of the frequencies and inversely related to the square of the speed of the light. It means that the spectral radiance is directly related to the cube of the frequency and inversely related to the speed of the light. Greater will be the frequency, it means that twice will be the frequency, the greater will be the spectral emissive power per unit area per unit frequency of the particular radiation frequency, right? Now, what is photoelectric effect? The photoelectric effect is the phenomena in which the electrons are ejected from the metal when the light is incident on it. So basically, it is a phenomena when the light is incident on the metal surface, the electrons are ejected from the metal surface. The ejected electrons are known as the photoelectrons. So this phenomena is known as the photoelectric effect, and the ejected electrons, the photoelectrons. It is important to note that the emission of the photoelectrons and the kinetic energy of the ejected photoelectrons depend on the frequency of the light that is incident on the metal surface. So when the light is incident on the metal surface, it is important to note that the emission of the photoelectrons and the kinetic energy of the ejected photoelectrons depend upon the frequency of the light. Okay, the greater will be the frequency of the light, and when the frequency of the light is emitted on the metal surface, the greater will be the ejection of the electrons. The emission of the electrons and the kinetic energy of the photoelectron depend upon the frequency of the light, basically. So the process through which the photoelectrons are ejected from the metal surface is due to the action of the light, and this process is known as the photoemission. Now let's discuss about the uncertainty principle. Uncertainty principle is derived by German physicist and the Nobel Prize winner Werner Heisenberg in 1927. He formulated that the uncertainty principle states that we cannot know both the position and the speed of the particle, such as electron and proton, with perfect accuracy. So he described that we cannot find out the position and momentum of the electron with the great accuracy. We cannot find the exact position and exact of the momentum of the proton. Okay, particle. Sorry. Such as the proton and with electron with perfect accuracy, the more we nail down the particle position, the less we know about the speed, and vice versa. Suppose if we go down and find out the position of the particle, we cannot find out the speed of the particle. So it is if it is we are it is like that we are unable to find out both things at the same time, there lies the uncertainty, and we cannot find out exactly the momentum and position of the particle. So this is known as the uncertainty principle, and is given by delta p delta x, which is greater than h squared. You can see in the diagram momentum distribution and the position distribution. It states that we cannot find out the position and momentum of the particle with the great accuracy, and suppose if we find out the position of the electron, we cannot describe the momentum of the electron. So this is known as the uncertainty principle. So there are the 6 principles that we will study in the quantum mechanics: principle of space and time, Galilean principle of relativity, Hamilton's principle, wave principle, probability principle, and principle of indestructibility and increability of the particles. So what is quantum mechanics? Quantum mechanics name quantum come from the Latin word which means how much, and reflect the fact that quantum models always involve something coming in. Quantum mechanics science deals with the behavior of matter and light on the atomic and subatomic particles. So basically it describes the behavior of the matter and light in the atomic and subatomic scale. It attempts to describe an accurate account for the properties of the molecules and atoms and their constituents, electrons, protons, neutrons, and other particles, gluons, quarks. So basically, the properties of the molecules and atoms and their constituents are described by the quantum mechanics. Quantum mechanics is an important tool to understand at the theoretical level the electronic structure of the chemical compounds and their mechanical mechanism, thermodynamics. So what is the uses of the quantum physics in our daily life? It is used in the computer and smartphones. The entire working process of the computer is based on the quantum physics. The phenomena of the band structure which supports the modern semiconductor based electronics is fundamentally a quantum mechanics. Laser and telecommunication, the base of the fiber optic telecommunication is the quantum physics. So basically the entire working of the computer is based on the quantum physics. The structure is derived from the semiconductors, transistors, and it depend upon the function of the particles as well, which involves basically electrons. The base of the fiber optics telecommunication is another invention of the quantum physics. So quantum mechanics is the fundamental theory in physics that provides a description and physical properties of the nature at the scale of atomic and subatomic particles. So we have discussed in details about the quantum physics, and next further we will study about the quantum physics, one of the fundamental and the toughest branch of physics that most of the physicists are unable to understand. But I have given the brief review and the most knowledgeable review about the quantum physics, where I have discussed about the fundamental topics of the quantum physics as well, which include Heisenberg principle, uncertainty, and the photoelectric effect, and the black body radiation, Max Planck solution to the black body radiation. I hope that you people enjoy the video. Keep like, share, and subscribe to my channel. And due to a lot of hard work, I expect to I expect the same reward. So I want views on my videos, I want subscriber for my channel. Thank you so much, and keep up the hard work, and do like, share, and subscribe to my channel. Thank you so much. Allah Hafiz.